Welcome to AI for Specialists. Today, our mission is really to cut through some of the noise. We want to uncover what a senior machine learning engineer actually does, to get past the media hype and look at the operational reality, the day-to-day.
Yeah, it's a really important distinction to make because the public often pictures, these ML engineers as purely theoretical types, maybe tucked away designing algorithms. But the reality, it's much more grounded. They're essentially specialized systems engineers. They build and critically maintain the complex machinery that actually makes AI work in the real world.
So, less lab coat, more hard hat, maybe.
Something like that. Think of this deep dive as mapping out that journey, from just being a model builder to really becoming a systems architect.
Okay, systems architect. I like that framing. So let's strip away the hype then. What does a typical day really involve for someone senior in this role? Are they constantly dreaming up brand new, groundbreaking algorithms?
Not really, no. That's a common misconception, and this brings us straight to something pretty fundamental. The 80-20 rule.
The 80-20 rule.
Yeah. You find roughly 80% of the actual effort, the complexity, goes into dealing with data and the underlying infrastructure. Only about, say, 20% is focused purely on the model itself.
80% on data and infra.
Wow. Exactly. So senior ML engineers day, it often kicks off with system monitoring, checking dashboards, looking at alerts, making sure everything's running smoothly. Then there's a huge amount of collaboration, talking with product managers to figure out requirements, working with data scientists to turn maybe a prototype into something robust for production, liaising with other software engineers to integrate the ML parts into the wider system. It's very team-oriented.
Okay, so lots of communication, lots of checking systems.
Yeah.
What about the coding part?
Right. When they are coding, it's often less about inventing algorithms and more about building really solid data pipelines, maybe defining infrastructure as code, automating the whole MLOps lifecycle, machine learning operations, right?
Yeah.
Getting models deployed and managed reliably.
MLOps, yeah.
And here's a detail that kind of sums it up. It's not unusual for a senior engineer to spend quite a bit of time just tuning. Tuning established, powerful models like, say, XGBoost.
XGBoost, the gradient boosting one.
That's the one. It really shows where the practical impact often lies, getting proven tools to work perfectly in a specific context, rather than always inventing.
Right, so it's less about designing a completely new engine from scratch and much more about ensuring that this existing powerful engine runs smoothly, reliably, and crucially at scale.
Yeah.
That points to a really different skill set than maybe people assume. What does this systems architect actually need to know? It sounds like quite a mix.
It absolutely is. It's this kind of duality of skills. On one hand, you need really deep technical chops. Strong software engineering fundamentals are non-negotiable. You need expertise in cloud platforms, think AWS, GCP, Azure, and mastery of the MLOps toolkit, things like Docker for packaging environments consistently.
Right, so things run the same everywhere.
Exactly. And CI/CD pipelines for automating how code gets tested and rolled out. Workflow tools like Airflow or Kubeflow for managing those complex data tasks. And of course, you do need a practical grasp of ML theory and the math behind it, but always viewed through the lens of real-world application, not just theory for theory's sake.
Okay, so the hard technical skills are key. What's the other side of that coin?
That's where the strategic and collaborative skills come in. You need to be able to communicate complex technical ideas clearly, especially to people who aren't technical experts. You need good business acumen, understanding how the ML work ties back to, actual business goals, the KPIs. Technical leadership is important too, mentoring others, setting direction. And underpinning all of that is a really strong systems thinking mindset, seeing the whole picture, not just the individual parts.
So the ideal senior ML engineer, they're not really a data scientist who can code a bit better.
No, I'd say it's more accurate to think of them as a systems engineer who really understands data and machine learning deeply. That perspective shift is key.
That really sharpens the definition. Now, you mentioned the complexity of getting ML into production reliably. What are the biggest hurdles, the sort of core challenges or pillars that define robust production-grade ML?
Right, that's a critical question. What actually makes an ML system trustworthy and usable out there in the wild? I tend to think of it as 4 interconnected pillars. First up, data provenance and the audit trail.
Provenance, like where the data came from.
Exactly. Especially in regulated fields like finance or healthcare, you absolutely must have a clear, traceable record for all your data, from its origin through every single transformation it undergoes. It's fundamental for compliance, for transparency, for debugging.
Okay, pillar 1, track your data meticulously. What's next?
Pillar 2, the economics of data quality. And this one's huge. Bad data isn't just an annoyance, it's incredibly expensive.
How expensive are we talking?
Well, studies suggest the average firm might lose something like $12.9 million annually just due to poor data quality.
Wow,
Yeah.
that's staggering.
It is. So senior engineers don't just hope for good data. They design for bad data. They build automated cleaning steps, validation checks, monitoring, essentially building quality assurance right into the system's architecture to guard against that cost.
Makes sense. Build the defenses in. What's pillar 3?
The reproducibility mandate. This is non-negotiable for serious ML. You have to be able to recreate any experiment, any result exactly.
How do you ensure that? Seems tricky.
It requires discipline and tooling. Rigorous version control for everything, Git for your code, obviously, but also tools like DVC, data version control for your data sets and your model artifacts, and then using things like Docker again to version the entire computational environment. So code, data, environment, all versioned together. Then you use experiment tracking platforms like MLflow or weights and biases to tie it all together and log results.
Got it. Version everything, track everything, and the final pillar.
Pillar 4, post-deployment vigilance. Basically, continuous monitoring after the model is live. Models aren't static, they degrade.
Degrade.
Usually through things like data drift, where the input data starts looking different from the data it was trained on, or concept drift, where the underlying relationship between the inputs and the output actually changes over time. Maybe customer behavior shifts, for example.
Okay, so the world changes and the model gets stale.
Precisely. So senior engineers architect the systems to constantly monitor model performance, check for data quality issues, detect drift, and importantly, they often design automated responses too, like triggering alerts or even automatically kicking off a retraining pipeline.
So these 4 pillars, provenance, data quality economics, reproducibility, and monitoring, they're not separate things, are they? They sound deeply interconnected.
Absolutely. They form a cohesive system. You can't really succeed at one without addressing the others. It all needs to work together, ideally managed within a unified MLOps framework.
Connecting this back to someone's career then, how does embracing this systems view change the trajectory for an ML engineer as they become more senior?
Oh, it's a fundamental shift, a profound one, really. You move from focusing on optimizing a single component, like tweaking a model for slightly better accuracy on a static test set, to optimizing an entire process, the whole ML lifecycle, end to end. Junior engineers might obsess over that model accuracy number.
Right.
Senior engineer, the systems architects, they're thinking bigger. They're thinking about scalability, maintainability, reliability, cost effectiveness, and the long-term business value the system generates. They take ownership of the whole thing.
And this links back to education, doesn't it? You mentioned the 80-20 rule earlier.
Yes, and here's a critical point, I think. Many academic programs, understandably perhaps, tend to focus heavily on that 20%, the model building, the theory, the algorithms, which is valuable, of course, but it can leave graduates somewhat unprepared for the reality of industry, where that 80%, the data engineering, the infrastructure, the MLOps, really dominate.
So there's a gap between academic focus and industry needs.
Often, yes. The real challenge, and where the senior engineers provide immense value, is in building that reliable, evolving system that delivers results continuously, not just creating one perfect model on one clean data set in a lab.
Okay, this has been incredibly clarifying. Let me try and synthesize this for you, our listener. The senior ML engineer, fundamentally, isn't just an algorithm expert. They are a high-impact software and systems architect. Their main game is building robust, automated, reliable systems encompassing data pipelines, MLOps, sophisticated monitoring that generate real, measurable business value. The core expertise is pragmatic engineering.
That's a great summary, exactly right. And maybe a final thought for you to ponder. If we accept this view that the senior ML role is primarily architectural, systems-focused, how should that change things? How will recognizing this properly reshape how we train people, how companies hire, and ultimately how we value AI talent in the years ahead? It's something worth thinking about.
Very pertinent question indeed. Well, that's all the time we have today. Until next time on AI for Specialists. Bye-bye.